Student, this is the 16th part of functions. So in 15th part I started a advanced model test number 4. I explained few problems, 3 completed. Now 4th problem, statement type, reasoning type. How to answer reasoning type already explained. Statement 1 true, statement 2 also true, statement 2 is the correct expression of statement 1. You can choose one is the answer for that question. Statement is true, statement 1 is true, statement 2 is also true, and statement 2 is not correct explanation of statement 1. You can choose 2 is the correct answer. Statement is 1 is true, statement 2 is false, we can choose 3 is the correct answer. If this is false, this is true, you can choose 4 is the answer for the problem. Okay. So your first problem, statement 1, the range of x square by 1 plus x square is closer 0 to 1. So f of x is given here, that is x square by 1 plus x square. Range should find, you know the procedure, y equal x square by 1 plus x square. You want to make x as subject, after that you can find, that is one of the method for this type of problem, easy problem this one. So add 1 and subtract 1 in numerator. So what will get? Y equal to 1 minus 1 by x square plus 1. So what is it showing? Your y value should be lesser than 1, not equal to 1. This never 0, this value never 0. The meaning of that, your y value should be less than one thing. And what this saying that? What this saying that your y value should be greater than 0. This never negative, no. RHS never negative. This LHS should not be negative. Okay. What is the meaning of that? Your y value may be 0. If x is equal to total 0. Other than that, what happens? Greater than 0. This saying that I will write. This saying that your y is greater than or equal to 0. This saying that your y less than 1. What is the meaning of that? Y belongs to closed 0 to open 1. So for this problem we can solve in this way. I can say that range of this function is closed 0 to 1 is correct statement. Is correct. Students, we have another alternate methods to find the range. I already explained general method, standard method. For this problem again I will explain. Y equal x square by 1 plus x square given. What x y real is domain, what y x is real is range. So y plus yx square equal to x square, or x square minus yx square minus y equal to 0. This is you can x square common, 1 minus y equal to y nana. So x square equal to y by 1 minus y, or x equal root over y by 1 minus y. Okay, x is a real number, that should implies y by 1 minus y should be greater than or equal to 0, or y by y minus 1 should be lesser than or equal to 0, because I don't like negative symbols in front of y. So use sign schema Weaver method, 0 1 plus minus plus. So 0 will satisfy, but 1 won't satisfy denominator. So negative symbols you want, what I can say, your y belongs to closed 0 to open 1. So this showing that the range of the function is closed 0 to open 1. Okay, that's why what I can say, statement 1 is true. Yeah, statement true. If f of x is lesser than or equal to g of x, then the range of this function is closed 0 to 1. Oh no. So without knowing their rules, we can't say none. Without knowing their rules, we can't say that if f of x lesser than g of x, what is the meaning of this? It's not clearly mentioned. Maybe degree or what. Okay. So here with using these rules, we can't conclude this. That's why I can say this is false. Okay. So 1 is true, 2 is false, means I can move with the 3 is correct answer for this. Okay. Next, fifth problem, statement 1, f of x equal to, what is this? Then range. Range of this function is singleton set 1. Already we proved now this constant function. Simplify this, we will get 1 only. F of x equal to 1. Already we did. Means what is the meaning of that? Range of this function is singleton set. What is given? That statement is true. Next, range of constant function is a singleton set. This is also true. And this correct explanation of this, I can move with the option 1. Okay. Next, students, comprehension type questions. Some information is given. By using this information we need to solve 6, 7, 8. What is the information? By use what is here given? So how to find the domain of the function? That's all. That is the information. So sixth problem directly I want to find, and observe here, f of x is given as root over x minus 2 by x minus 3. Okay. So what is the meaning of that? X minus 2 by x minus 3 should be greater than or equal to 0. 2, 3 plus minus plus 2 will satisfy, but 3 won't satisfy because in denominator we want plus symbols. So I can say x belongs to minus infinity to close union open 3 to infinity. This is the domain of the function. Where is that? Here. Fourth is correct for that. Yeah, next, similarly seventh also none. F of x is given as root over 3 minus x by 4 minus x. Same, 3 minus x by 4 minus x should be greater than or equal to 0. Take minus common in numerator and denominator. What will get? X minus 3 by x minus 4 greater than or equal to 0. Number line 3, 4. 3 will satisfy, but 4 won't satisfy. Open circle. Plus, minus, plus. We want positive symbol. X belongs to minus infinity to 3 closed union open 4 to infinity. Is the range of domain of the function. So minus infinity to 3, 3 closed 4. I will move with 4. Okay, students. Yeah. Next, eighth problem. Root over 2 minus x by x minus 7 f of x equal to. So what I can say here, 2 minus x by x minus 7 should be greater than or equal to 0. Here I don't like a negative x here. That's why in numerator I want to take minus common. X minus 2 by x minus 7 greater than or equal to 0, or multiplying minus another side, x minus 2 by x minus 7 lesser than or equal to 0. Number line 2, 7, 2 will satisfy, but 7 won't satisfy. Plus, minus, plus negative symbols you want, means that x belongs to closed 2 to open 7. This is the domain of the function. Closed 2 to open 7. This is the correct answer. Okay, students. Yeah, next matrix step nanu. Range of mod x. You know the graph of mod x. The range means closer 0 to infinity. Okay, for any modulus function is given, that mod f of x also given, no problem. Its range is closer 0 to infinity. Okay, here x minus 3 given, x is 3, 0. Other than that, greater than 0. That's why I can say the range of this function is closer 0 to infinity. I can move with R. So I think B is tougher one. F of x is given as mod x plus mod of x plus 1. One of the way you can draw its graph, through graph you can find, but graph concept not yet started. So general method means we want to open modulus symbol on here. 3 cases will arise. X lesser than or minus 1 case. In this case, what happened to f of x I will write. Okay. This case of negative, no? Minus x minus 1 minus 2x minus 1. So minus 1 less than x less than 0 case. What happened to f of x? There is minus x, yeah, plus x plus 1, that is equal to 1. So x greater than or equal to 0, 2x plus 1, that is f of x. So what I can write here? Okay, now f of x of 3 pieces. First piece, what is that? Where is that? Okay, minus 2x minus 1 for x less than or equal to minus 1, 1 for minus 1 less than x less than what? 0. Okay, last one greater than or equal to 0, 2x plus 1. Yeah, 2x plus 1 for x greater than or equal to 0. This is the function. By using this function, we want to find range. For this x, I will find what the range of this. For this x, I will find range of this. For this x, range. Okay, after that, I will find total range. Okay. First of all, x lesser than or equal to minus 1. Then what happened to this? Multiplying minus inequality will alter. Minus 2x greater than or equal to 2. You need to subtract 1. Minus 2x minus 1 greater than or equal to 1. What is the meaning of that? This value is closer 1 to infinity. First part is closer 1 to infinity. That is the range. Second part is 1 only. Okay. So, third part x greater than or equal to 0. Okay, I will write that. X greater than or equal to 0. What happened to 2x plus 1? So, here we want to make 2x plus 1. 2x greater than or equal to 0. 1 added greater than or equal to 1. What is saying that? 1 to infinity. What is saying that? 1 to infinity. Okay. Totally 1 to infinity, 1 to infinity. So, total is 1 to infinity. Not this, wait. This is 1 to infinity. Okay, students, our next problem. C. F of x is equal to root over mod x minus x. We want to find range. Before that, first of all, you want to find domain. Domain means modulus of x minus x should be greater than or equal to 0. Or modulus of x greater than or equal to x. This is true for all x, means x is a real number. Observe now. Only mod x greater than x means different. For this only x should be negative real numbers. But what is r equal to given? Take any real number and substitute it, you get true statement only. Put x equal to 2.1 minus. Okay, modulus of minus 2.1 greater than or equal to minus 2.1, correct only. Take 3, mod 3 greater than or equal to 3, 3 greater than 3, correct only. R equal to is there, that's why. So what I can say, domain is all real numbers. Now I want to find range. So what, instead of x, any real number you can take, any real number. For example, 2 is taken, 2 is taken. What happened to 0? Okay, mod 2 only 0. So we are getting 0. This root over means 0 and more than 0. Now we have to identify 0 and more. 0 are getting more than 0. For example, x is taken as a minus 4, for example. Modulus of minus 4, minus of minus 4, that is, we will get root 8. What is the meaning of this? Your range is closer to 0 to infinity. So that's why I want to move with this. Okay. Next, root over x minus 5, f of x. This is also closer to 0 to infinity only. Root over closer to 0 to infinity. Actually, by using this graph directly, you can say its graph will be like this. Okay. So what is the meaning of that? This range also same. What I can say, first one is R, second S, next R. This is the answer for the problem. Okay. Yeah, very important concept, students, this one. Inverse trigonometrical functions. Inverse. Actually, what we have trigonometrical function, I will write sin x, cos x, tan x, cot x. Or these are trigonometrical function, just a trigonometrical function. F of x equals sin x, f of x equal cos x, f of x equal tan x. Okay, f of x equal cot x, f of x equal secant x, f of x cosecant x. These are trigonometrical functions. Okay, basic trigonometrical functions I can say. Okay, what the domain here? All real numbers. Range closer to minus 1 to 1. What the domain? All real numbers. What the range? Minus 1 to 1. What the domain? All real numbers except the angles of the form 2n plus 1 into pi by 2 where n belongs to z. What the range? All real numbers. What the domain? All real numbers except the angles of the form n pi where n belongs to z, and range is all real numbers. Secant also defined. Domain is this. Range is minus infinity to minus 1 union 1 to infinity. So these are about trigonometrical function, basic trigonometrical function. What are basic inverse trigonometrical functions? That is important thing. Students, listen. f of x is given as 2x plus 1 is a function defined from R to R. What is f inverse of x? Question mark. What is the meaning of this? What is the inverse rule for inverse function for this? So I already explained, no? For example, f is a function from a to b. F from b to a is a relation. Sometimes the relation is functional relation when f is a bisective. Clearly explained. So for existence of inverse, given function should be bisective. Then only b to a also another function. If f is a function from a to b, okay. So you want to create a new function b to a. What type of function f should be? Bisective. Then only inverse exists. Discussion already completed. Inversible function, that one. So here what is the question here? F of x is 2x plus 1. What is the inverse of x means? What is the inverse rule for inverse function? First of all, exist or not, that should identify. How can you identify? First of all, you need to check whether it gives 1 1 or not, 1 1 and onto or not. So linear equation 2x plus 1, obviously it is a straight line and the coordinate point is 1 1. Onto, how to find onto? You need to find range should be equal to codomain. So y equal to 2x plus 1, 2x equal to y minus 1, x equal to y minus 1 by 2, whatever may be y, x is real only. What is the meaning of that? Range is real number, range is called codomain. So it is onto 1 1 and onto. Now you can find its inverse relation. For every function you can find inverse relation, but that inverse relation may not be functional relation. Okay, here what happened? Inverse also function, because it is 1 1 and onto. How to find inverse rule? Okay. So first of all, no, you want to find inverse rule. First of all, you want to check whether given function is 1 1 or onto or not. Okay, bisective or not. I verified 2x plus 1 from R to R is a bisective function. Now you can find its inverse. Already I explained the procedure. What? Let y is the image of x, means f of x equal to y. Then x is equal to what? F inverse of y. Relation number 1. F of x means 2x plus 1 equal to y. What I am doing here? X is paired with y under the rule f of x. Y is paired with x. What rule? So this is acting just like x. This will be acting just like y at last. So before that, y to x rule I want. After that, instead of y I will write x, instead of x I will write y at last. So you want to make x as subject. 2x equal to y minus 1. X equal to y minus 1 by 2. So instead of x, what I can write? This I can write. F inverse of y I can write. F inverse of y equal to y minus 1 by 2. Okay, here y is a dummy variable. You can call dummy variable. Anything you can write instead of y. Okay, so in f inverse of k also I can write. That is k minus 1 by 2. Or instead of k also, x also I can write. F inverse of x equal to x minus 1 by 2. This is the inverse rule for this function. Inverse also bisective only. So what the rule means? I can say that f inverse of x equal to x minus 1 by 2. Similar way, if trigonometrical functions are given, how to find its inverse? That is today's concept, important concept, students. Okay, listen. If f map R to R defined by f of x equal to sin x, then find f inverse of x. Okay, this is the question. What he asking? Find the inverse rule for this function. First of all, you want to check this function is bisective or not for this domain and this codomain. If it is bisective, then you can find its inverse. Now I want check. Okay, find take any r to r, no, r to r, r to r. Take 0, nana. Sin 0, what? 0 only. 0 paired with 0. Take pi. What is sin pi? 0 only. These two are different, but image is same. These two are different, image is same. Not 1 1. Not 1 1. Not 1 means inverse won't exist. We can't find its inverse. Understood? Okay. So R to R, it is not 1 1. Oh, to make one. Actually we want to find no inverse. What should do? We want to modify the function. We want to modify the function. We want to modify the domain and codomain. No, I don't want to take R here. I want to take something. After that it will become a 1 1. Okay, I will show you through graph. Okay, first of all, student, draw the graph of sine function. Without graphs you can't learn the concepts of functions and limits and differentiation. So this is the basic graph of sine function. Okay student. Okay, 0 here, pi by 2, this is pi, this is minus pi by 2, this is minus pi. Clearly this function is not 1 1, no? It fails horizontal test. See here, the graph intersecting a horizontal line intersecting graph at several points. Draw one more line also, no problem. It intersects several points. Means what is the meaning of that? Different x will get same y. That's why it is not gives 1 1. So R to R not 1 1. That's why I want restrict domain. I want restrict the domain. So I want take domain from minus pi by 2 pi by 2. What happened? Observe now. If x is taken as minus pi by 2 pi by 2, automatically this one only the graph of the function. This piece only the graph of the function. So this is only sine graph from minus pi by 2 pi by 2. Your wish, you can take this piece also, minus pi by 2, 3 pi by 2 also can take, no problem, no problem. But standard method I am using here, standard intervals I am taking here. If you take your axis from minus pi by 2 pi by 2, so what is your graph, Nana? So this is only your graph. This is only the graph of sine function. Okay, 1 minute. This is only the graph of sine function. Observe, Nana. It satisfies horizontal line test. Draw any horizontal line. It intersects the graph at only one point. Observe any one. Means what happened? If your domain is taken as minus pi by 2, this is the sine graph. This sine graph is 1 1. Okay, that's why what I want to change the domain of the function. So what I can say? So minus pi by 2 to pi by 2 to R. Now what happened? F map minus pi by 2 to pi by 2 to R. The function f of sin x is 1 1 clearly. Not only this piece, no, in this piece also can take my pi by 2 to 3 by 2 also can take that. In that interval also it is 1 1. That is not big problem. Okay, but standard interval is minus pi by 2 pi by 2. Okay, students understood? What happened, Nana? I modified domain. If domain is modified, it become a 1 1. But it should be, if inverse exists, it should be bisect, no? It is also onto. Here not onto. Observe here, na? What is the range? What is the range of this? For this x corresponding y here only. For this x corresponding y, your output is from minus 1 to 1 only. This is minus 1 1. Your output is minus 1 to 1 only. Range is minus 1 to 1 only. The range is not equal to codomain. That's why it is not onto. It is not onto, then it is not bisective. It is not bisective, it is not inversible. We can't find its inverse rule. Understood? That's why I want to modify codomain also. I want to modify codomain as minus 1 to 1. Now observe. F map minus pi by 2 to pi by 2 to closed minus 1 to 1 defined by f of x equal to sin x. What had happened to this, Nana? It become 1 1 as well as onto. It is bisective. Then you can find its inverse. Understood? Okay. That one I want to write. Students, very important. Yeah. F maps R to R defined by f of x equal to sin x is not bisective. So its inverse won't exist. Its inverse does not exist. Okay. Now what should do? We need to modify domain and codomain. If f map closed minus pi by 2 to pi by 2 to closed minus 1 to 1 Okay, defined by f of x equal to sin x is say bisection. Therefore its inverse exists and its inverse is denoted by sin inverse of x. Okay, or arc sin x, both are same, inverse function. Okay, no, what happened? So general sin function not bisective. For general function we can't find the inverse. So after modifying domain and codomain, it become bisective. Then I found the we can find its inverse. Students listen. F is a function 1 to AB. One period with B, this period with f of f function from A to B. What is the domain of f function? Set 1 to. What is the range? AB. If inverse function, f inverse from B to A. What is the domain? A to B. What is the range? 1 to. What happened? The domain of f become range of f inverse. The range of f becomes domain of f inverse. Actually, this is the domain of which function? Sin function. This is the range of sin function. So sin inverse of x function is there, that is from B to A, reverse. For example, this is A, this is B. So B to A. For this function, this become the domain and this become the range. Okay, that should I write. Okay, where I should write? Next page I will write. Okay. So domain of f, that is minus pi by 2 comma pi by 2 becomes okay range of its inverse. Its inverse in bracket sin inverse of x. Okay, similarly the range of f, that is minus 1 to 1 becomes domain of its inverse, that is sin inverse of x. Students, this is very important. So I am finalizing. Yeah, what is that? F of x equal to sin inverse of x or A or C x, sin x, both are same. What is the domain? Domain equal to minus 1 to 1, don't confuse. Range equal to minus pi by 2 to pi by 2. Okay, sin inverse of x, your input is this, your output is this. Okay, so this is about sin function. Okay, so what happened, students, listen. Sorry. Yeah, listen all of you. Here pi by 2. Yeah, 1 2. Here minus pi by 2. Yeah, this is the graph of sin function. Minus pi by 2, pi by 2. But you want the graph of sin inverse of x, important. Students, listen. F of x is, sir, f is a function, f inverse another function. How directly we will get the graph of f inverse from f or f from f inverse? Okay, so the graph of f inverse function is image of f with respect to the line y equal x. or the graph of f is reflection image of f inverse of x with respect to reflection image of f inverse of x with respect to the line y equal x. Understood? So what should do Nana here? So we want to do one thing. Y equal x means a straight line. Y equal x is a straight line passing through origin. This is y equal x straight line. Reflection image should find reflection image. So just I'm trying Nana. I'm trying to explain this. So this is the image of this portion, and this is the image of this portion. Okay. So the black color one is the graph of sine inverse. But what happened to this becomes, sorry, exactly here only, but my diagram is not correct. Actually this is pi by 2. This pi by 2 becomes minus 1 plus 1 for sine inverse function. This minus pi by 2 becomes minus 1. This minus 1 becomes minus pi by 2. This becomes, sorry, this plus pi by 2, this is minus pi by 2. So what happened? Rough sketch of sine inverse of x is this, Nana. Rough sketch. Your sketch will be like this. Should remember, Nana. This should remember. So this is pi by 2, this is minus pi by 2, this is 1, this is minus 1. This is the graph of sine inverse of x. So red color one is sin x graph, this black color one is sine inverse of x graph. Graphs concept is very important. So these are basic graphs. You should remember what is the sine graph, basic graph, what is the sine inverse of x graph. Now onwards. Sine inverse of x means you should remember like this. This is y axis, this is x axis, okay, bounded by two straight lines. Actually sine function bounded by y equal to 1 and y equal to minus 1, but here y equal to pi by 2 and y equal to minus pi by 2. Okay, so your graph will be like this, Nana. Okay, here corresponding minus 1, here corresponding x 1. So this is pi by 2, this is minus pi by 2, this is the graph of sine inverse of x. Okay students, observe here. See, graph of y equals sine inverse of x. Observe here. Okay, this is graph of cos inverse of x, graph of tan inverse of x, graph of cot inverse of x, secant inverse of x, cosecant inverse of x. Actually I require so much time to explain all these things. Just I explain only sine inverse of x function, its nature. Similarly, I want to explain cos and tan and cot and secant, cosec. I need time, so I will try to explain remaining things also. Second one is, what is that? Cos function. I will write f map R to R defined by f of x equal to cos x is not a bisective. How can you say? Through graphs only. This is the graph of cos function, basic graph. So my plus 1 and minus 1. See, it's not 1 1. Horizontal test failing, not 1 1. Okay. Even though not onto also, because range is minus 1 to 1, here codomain is capital R. Not 1 1, not onto. For this domain and codomain, we need to modify. Again, what should be taken as domain? That is interesting thing. So you need to take this piece. This piece means 0 to pi. 0 to pi. Not only 0 to pi. This portion also can take. This portion also can take. Standard one is 0 to pi. 0 to, if input is taken as 0 to pi, I will write 0 to pi. Input is 0 to pi. If 0 to pi, this is the graph. For this graph, it is 1 1. Not onto, because again still it is range is minus 1 to 1 only. But here codomain is capital R. That's why codomain also should change. What I am saying, to minus 1 to 1. So f map 0 to pi to minus 1 to 1 defined by f of x sin x is inversible, bisective. Then after you can find its inverse. Okay, Nana? But if f maps closed 0 to pi to minus 1 to 1 defined by f of x equal to cos x is bisective or inversible function. So its inverse exists. Okay, and it is denoted by cos inverse of x or arc cos x. Now I want to write this definition clearly, so this is important. F maps. Okay, now I want interchange this minus 1 to 1 to 0 to 1, 0 to pi. The function f of x equal to cos inverse of x is also bisective, no problem. Okay, a function is different like this, f of cos inverse of x. So this is bisective, 1 1 and on 2. What the domain of this? This is the domain. What the range? This is the range. Understood? What happened? Actually, this is the range of cos function. This is the domain of cos function to become a bisective. After finding its inverse rule, so these two also interchange. This become the domain, this become the range. Now onwards, what is the cos inverse of x domain? We should remember this. See here, cos inverse of x domain and sin inverse of x domains are same, but the ranges are different. Range of sin inverse of x is minus pi by 2 pi by 2 closed. Range of cos inverse of x is 0 to pi closed. Okay, students? Okay. Same procedure, how to draw its graph, that also important. Yeah, what is this? Actually, this is the graph. This is the graph of sine function. Here pi, here cos function. This is the graph. With respect to y equal x, we want to find the reflection image. Okay. So what we will get? How we will get means this is the graph. So this is the graph. So remember this. X axis, y axis. Okay. So this is the graph. This is 1. This is minus 1. This is 0. This is pi. In this way, we need to remember now. Okay. Okay. Similarly, remaining things also defined. Tan inverse of x graphs important. Graphs very important. Okay. Actual tan graph what? This is a tan graph from minus pi to pi by 2 to pi by 2. After this, totally is not 1 1, but if you take your domain is minus pi by 2 pi by 2, this is the graph. This is 1 1 and also onto bisective. If you take tan function minus pi by 2 to pi by 2, okay, Ranan? So this is the graph, and it bisective, inverse exists, inverse rule is tan inverse of x. So this graph is like this. Okay, this is y equal to pi by 2 line, this is y equal to minus pi by 2 line. Okay, domain is all real numbers. Range is minus pi by 2 pi by 2 for tan inverse of function. No. Domain is all real numbers. See, domain is all real numbers. For this, what is the range? Capital R. That becomes the domain of the tan inverse of function. But here, what is the domain? Minus pi by 2. That becomes the range. That's why tan inverse of x given, domain is all real numbers, range is open minus pi by 2, open pi by 2, because at pi by 2 tan won't define. No? Like the remaining things are defined here. I will make a list for this. No? You should remember. Okay, graphs and the domains and ranges. Students, these are the graphs of all 6 standard inverse trigonometric ratios, and this is box showing that their domains and ranges. Everyone should remember none. Okay, you can solve problems based on this table. Sine inverse or arc sine function, domain is minus 1 to 1. Okay, these two are easy. Tan domain or this is range. Yeah, cosec or sec both are same here. Their domains are same, but ranges are different. Observe here. Here minus pi by 2 pi by 2 excluding 0, 0 to pi excluding pi by 2. Okay. Yeah, last one, cot inverse x. Domain is all real numbers. Oh shit. This is wrong, Nana. So open 0 to pi. So this is the range of card function. You should remember all these things. Okay student, now I want to explain this problem. Last part I didn't explain this one because inverse trigonometric function. What is asking, what is the domain of tan inverse of 5x? What is the domain of tan inverse of x? All real numbers. All real numbers. So tan inverse of 5x also what happened? All real numbers only, no? Okay. So all real numbers is the domain. All real numbers is minus infinity to infinity. That is the domain of tan inverse of 5x.